Hello, my name is Ilia, as she said. I'm presenting a joint work with Julie Winkman from University of Haifa. Okay, let's start. Let's start with defining the task. Given a parallel corpus, meaning a corpus with two languages, that one is translation of the other, our goal is to detect which one of the languages is the original and which one is translated. There have been many previous work regarding detection of translation needs, meaning the sublanguage that is created when in the process of translation. But all of those works, either they dealt with monolingual corpus or dealt with parallel corpus, but they used a very big chunk of data, meaning a few hundred or 1,000 words. In our work, we use only the smallest text as possible, sentence pairs. Let's start with an example. Here's an example in English and Bulgarian. And the question is, which one of them is original and which one is translated? Both of those sentences are coherent, it doesn't have any grammatic error, and translated by human. So there is nothing that pops up that can identify which one of them is translated or not. And this represents that this task is very hard even for humans. First, let's talk about the contribution of our paper. First, we present state-of-the-art results in this task. We reach up to 90% accuracy in some language pairs. The second one, we demonstrate the same method that works for several language pairs. And after experimenting with several language pairs, we came up with the hypothesis that the more the two languages are distant, meaning topologically, then this task of identifying translation is easier. And the third one is more practical. We show that if we take into account the direction of the translation, we can improve machine translation systems. Previous works show that this is valid only for statistical machine translation. In our work, we show this is valid also for neural machine translation, meaning neural machine translation doesn't overcome those differences between translated and the original. Now let's focus on the last one and show how we can how we show that the improvement in machine translation. So we defined that a quick reminder that when training neural machine translation, the input is sentence pairs. So we defined a task, translate from French to English, and we created 3 data sets. One, the first one, the sentence pairs, the French was original. The second one, in the sentence pairs, the English was original. And the third one, there is a mix of both of them. And as you can see in the results, the first one, the French original sentences, had the best scores in all 3 our measures, and the English original had the worst scores, and the mix of them, as expected, have something in the middle. Now let's go back to the task itself and talk more about it. We describe the methodology that we used. We approached this task in a more classical way. We designed a few features that came as an insight from translation studies. We used 3 datasets, Europal, UN Corpus, and Hansard. In all of them, the original language is annotated, and the translation is done by a human. And we approach this task as a classification task, where the baseline is 50%, and we use logistic regression as a classifier. In the next few minutes, I'm going to describe a few interesting features that we designed, and in the end, I will show you the results. First one is called MTUs. Let me quick reminder, when we have a lot of sentence pairs, we can run a statistical process and identify which word is aligned to which word in source and target languages. After we have those word alignments, we can group them into a unit, such that the links between the words stay in the units, and we can decompose those units into smaller ones. This is called the minimal translation unit, MT. This is the tough definition. Let's see an example. Here's English and French words, sentences. Those are the word alignments between them. and those are the minimal translation units. As you can see, this is results some sort of dictionary for those two sentences. And we wanted to see if there is something more general that we can say about those MTUs. So instead of using the words themselves, we converted them into part of speech tags. This is results part of speech MTUs. So let's see the same example. Those are the word alignments, those are the part of speech tags, and this is results, the part of speech MTUs. So we can see that proposition is mapped to proposition, verb with a preposition mapped to a verb, and a verb mapped to a verb again. But if you look at the second one, it's not just a verb with preposition, it's a specific preposition, it's the word to. So we wanted to do some refinement to this process, and instead of using only converting all the words to part of speech, we converted only the content word to part of speech, and leaving the function words as they are. And this is result what we call lexically anchored part of speech MTUs. Let's see in another example. Those are the word alignments, those are the MTUs, and those are the LA part of speech. As you can see, the content word continue is mapped to its part of speech, and the function words left as they are. And this is result a little more interesting results. We can see that the word will with a verb mapped to a verb in the future tense in French. And if we look at some of those MTUs, part of speech MTUs or LA MTUs, we can see that some of them are more frequent in one direction, and some of them are more frequent in the other direction. These features catch some the structure, the linguistic structures of the sentences. Another well-known phenomenon that happens in the translation process is that in translated text, the text tends to be more simple, meaning use more common words. And also this phenomenon well observed in big text, but in sentence pairs it's very hard to identify it. So we wanted to compare the words, the ranking of the words, but it's very hard to compare the absolute rank of one word versus the absolute rank of another word, because it's different languages. So instead of comparing the absolute words, we splitted the words, all of the words into bins, and created some sort of histogram from those sentences. The bins represent more frequent and until less frequent words. And again, when looking at those histograms, they are different whether they're one of the languages is original or when the other language is original. After defining, we designed some more features. You can read about them in the paper. After creating those features, we created a neural network just to compare how those features are related, the performance of the model with the features versus the performance in a modern architecture. We designed a very basic neural network. The input to the network was the two sentences. Were converted to pre-trained word embeddings with bidirectional SDM and fully connected layer in the end, and in the end it results prediction. This is a schematic view of the neural network. And after after we have the features and the neural network, we wanted to see if we can combine them and create some more stronger model. So we came up with a method that's called stacking. We created three feature set in the neural network. One feature set is features that relate only to English, for example, for one language. The second one are features that relate only to the second language, and the third one is features that relate to to both of them. For example, the MTUs that I described previously, and the neural network. All those 4 classifiers output some results, and we train another classifier that the input to it is the 4 results of the classifier, and he outputs the final prediction. This is the results that we got. Those are the features, and the numbers here represent accuracy in percent. Let me remind you that the baseline is 50%, and the all row represents a combination of all the features, and the stacking is the method I described before. We can see here that when combining when combining all the features, it results in much better results than each one of them separately. And also the stacking method has improvement over both of all features and the neural networks, in all of them except the last one. And one more thing that interesting in this result is that if you remember in the beginning I mentioned a hypothesis that the more the 2 languages are distant, then the easier the detection of translation. So we have here English versus Russian and English versus Arabic. In those 2 languages we get the highest results. And when comparing to English and French and English and German, where those 2 languages are very similar, then we have the lowest results. That's it to conclude. As I mentioned before, translation is more detectable when the 2 languages are more distant, and combination of features with neural network architecture can result some better model. But this should be more research for future work, how to combine those features into neural network. That's it. Thank you.